Now, if you're just learning VSEPR, it can be really hard. And chances are you might be making some very common mistakes that I'm going to talk about in this video. Okay, here's how it's going to work. I'm going to go through a bunch of the common mistakes that people make, and for each mistake, I'm going to say why it's a mistake, I'm going to say what's wrong about it, and I'm going to show you what the right answer is. I want you to pay close attention to each one of these mistakes, even if you're not making them now, because understanding the mistakes is one of the best ways to learn and make sure that you really understand something. Okay? So, here's a first example. NH3 or ammonia. What does it look like in 3 dimensions? What's its VSEPR shape? Okay? So, one of the biggest mistakes is people look at this molecule and they think that it's trigonal planar, okay? A trigonal planar molecule looks like this. It's got these 3 atoms around on the outside, and look, all of these atoms are flat in a plane. They're all straight in this plane, and that's why you call it planar for this plane. Okay. Now I think a lot of people make this mistake because they look at the structure of NH3 and they say, okay, there's 1 atom in the center, the N, and then there are 3 atoms around the outside, these 3 atoms arranged on the outside. So here's the atom in the center, and here are the 3 atoms around the outside. I think that's why they come up with this wrong idea here. But here's why it's wrong, okay? Because check out this. Look at this unshared electron pair here. It's very important. When people think this is trigonal planar, they forget to take into account the unshared electron pair, okay? So there are actually 4 things that need to be arranged around this nitrogen. Sure, there are 3 atoms, but then there's also an unshared electron pair. So this structure, NH3, actually looks like this, where you have the 3 atoms, but then we have an unshared electron pair here. Each one of these 4 things wants to push against the other, and they want to be as far apart as possible, okay? So this unshared electron pair, it's pushing the atoms down, and that's why it gives it this shape. We call this shape trigonal pyramidal, because it looks kind of like a pyramid. You can particularly see that if I hold it on its side. You can see that all of the atoms are bent down in this direction, and that's very different from the trigonal planar where they're all flat on this plane. Trigonal pyramidal is bent down because this unshared electron pair up here is pushing these atoms down. Sometimes when you're talking about VSEPR shapes, you need to know the angles between the bonds. So if I have my Lewis structure here, the angles between any of these bonds are about 107 degrees, okay? Now finally, if we're saying that NH3 is not a trigonal planar molecule, what is? Here are 2 examples. This one and this one are both trigonal planar. Look what they have in common. They have 1 central atom, and then they have 3 atoms around the outside, but they don't have any unshared electron pairs, okay? It's this unshared electron pair here on nitrogen that is what makes this trigonal pyramidal instead of trigonal planar. So always keep an eye out for these unshared electron pairs. If something doesn't have it, it's trigonal planar in this example. If it does, it's going to be trigonal pyramidal, okay? Let's look at some more. Okay, SH2. A big common mistake that people make is they look at this molecule and they say it has this shape. It's a linear molecule. And I think they do that because they see 1 atom in the middle and 2 atoms on either side. So they say, okay, a linear molecule would make sense. Here's a 1 atom in the middle, 2 atoms on either side. But the mistake they're making here is they're forgetting to look at this and this, which are the unshared electron pairs. These unshared electron pairs want to arrange themselves around the central atom just the way these other atoms do, okay? So the molecule is actually going to look like this. Here are the 2 atoms, but now here are the 2 unshared electron pairs, okay? And they are pushing against each other, and they're pushing against these atoms. All 4 of these things want to be as far apart as possible. So it will push these 2 atoms into this sort of bent shape. And we actually call this molecule, we call it a bent molecule. It's these unshared electron pairs on the central atom on S here that are bending these other two atoms down, okay? Now, something that I think confuses people is the way this Lewis structure is drawn. They say, but it's drawn as if all the atoms are in a row, okay? Well, there are a lot of correct ways to draw a Lewis structure. You don't always have to draw a Lewis structure to show what the actual shape of the molecule would be like. So don't get thrown off by something like this. But we could draw a Lewis structure like this that shows the shape a little bit more accurately. And if we were doing this, we might want to show the angle between these bonds here. And this angle would be about 105 degrees. So a bent molecule like this with two unshared electron pairs and two atoms will have about 105 degrees between them. Okay? Now, as I did before, let's talk about what molecules would look like that really were linear. Okay, if this isn't a linear molecule. These are two examples of linear molecules. Let me move this up here. And what you see here is they have one central atom and two atoms on either side, but there are no unshared electron pairs on the central atom. So all they have is these two atoms on either side and no unshared electron pairs. That's how you know that they're actually going to be linear. Let's look at one more example. This example, like the previous one, people look at it. This is ozone, O3. You know, it's up in the atmosphere. It makes the ozone layer. O3. They look at it, and just like before, they see it and they think, oh, I bet this is a linear molecule. 3 atoms, I bet they're all in a row like this. But as I keep saying, you're probably so sick of hearing me say it, is look at this unshared electron pair. Okay? This unshared electron pair is going to push on these other two atoms, and it's going to make a shape like this. Here are the two atoms, here's the unshared electron pair. And so this is also going to make what we call a bent molecule because of the push from the unshared electron pairs here. Now it turns out that the angle is a little bit different when you only have one unshared electron pair pushing. We saw a minute ago, where did I put that? That when you have two unshared electron pairs pushing, you have an angle of about 105 degrees. It turns out that if I were to draw this Lewis structure so that we could actually see the shape a little bit better, hang in here with me as I draw it, the angle between these two bonds would be about 116 degrees, kind of between 116 and 118, a little less than 120. So this angle is going to be a little bit bigger than when we have two unshared electron pairs. Okay, but either way, keep in mind that this unshared electron pair here makes it a bent molecule. It's not a linear molecule. Okay? So like the big common theme here is that it's all about unshared electron pairs. Don't just look at the atoms that are surrounding the central atom. Also have a good look at the unshared electron pairs that are on the central atom, and then figure out how they're going to be pushing the other atoms in this molecule. The last thing that I want to say is I want to give a shout out to the importance of Lewis structures. As you can see, VSEPR relies on Lewis structures. Okay, you got to look at the Lewis structure to figure out what the shape would be. So that means that if the Lewis structure is wrong, the VSEPR shape is going to be wrong too. So even before you start thinking about what the VSEPR shape is, make sure that your Lewis structure is right, or everything's going to be thrown off. There are a bunch of videos that you can find that talk about how to draw Lewis structures and then how to check your work and make sure the Lewis structures are correct. So always do that even before you start thinking about the VSEPR shape. But remember, don't forget about the unshared electron pairs, because that is probably what's going to throw you off.